A warm welcome to one and all in Dr. Abha Chemistry Pathshala. Let us just start with today's topic, which is method of preparation of ketones. Methods of preparation of ketone and methods of preparation of aldehydes are very similar. So before watching this video, I request you that please go through the methods of preparation of aldehydes. There are certain methods which are very specific for only ketone. We'll be talking about them in detail, and rest of the methods which we have already spoken about in aldehydes, we will not be talking about them in this video. So over to the screen for method of preparation of ketones. I will be taking aliphatic as well as aromatic ketones. So let's get started with the methods of preparation of ketone, and I am hoping that all those who are watching this video have already gone through the method of preparation of aldehydes. So you can see the link in the I button. If you haven't been through, please request you to first go through the video of method of preparation of aldehyde and switch over to the ketones later, right? And I will not be explaining in detail the common methods which are applicable for aldehyde and ketones both. So again, like in aldehyde, I will divide the method of preparation into three. That is, methods applicable only for aliphatic, methods applicable only for aromatic, and for common for both. So let's get started with the aliphatic ones. So for aliphatic ketones, the first method for aliphatic ketone, so this method was already taken up in the previous lecture. If you take any higher alkyne other than acetylene and you perform hydration, you add water in presence of Hg salt and H2SO4, it is a simple Markovnikov addition, and on the same carbon you get enanol, which tautomerizes to give you ketones. So let's move on to the next method, that is from selective oxidation of 2-degree alcohols. So this one you can check the previous video. Third, acid chlorides. You take Grignards and you react it with cadmium salt, cadmium chloride. What you get is dialkyl cadmium. You get dialkyl cadmium and you get byproduct of magnesium halide, and this dialkyl cadmium, it reacts with RCOCl to give you, let's take it as R double dash dash, just to distinguish between the alkyl groups. So what you get is R dash CO R, right, and you get CdCl2. Please remember, we are not taking RMGX directly on R dash COCl. Why we are not doing it? Because here also we could have got a ketone. We could have got a ketone with MgXCl, right? We could have done that, but what would have happened is this ketone would have further got reacted with MgX, right? It would have reacted with RMGX to give you 3-degree alcohols. So in order to avoid that, we are using dialkyl cadmium, and dialkyl cadmium, these are less reactive. These are less reactive towards nucleophilic addition reactions, which is right. So that's why we don't get alcohols. So let's move on to the next one. In category, I'll be talking about only aromatic ketones. A very simple reaction where you take benzene and you make it undergo Friedel-Crafts acylation in presence of anhydrous AlCl3, and you get acetophenone. You can get other derivatives as well, right? So you get a ketone and you get HCl. So this is for aliphatic plus aromatic. The first one can be, we take nitriles. So we can take RCN or we can take, right? So we take RCN and we react it with phenyl magnesium bromide. So there will be a nucleophilic addition reaction on RCN. So what you get is, this get an MgBr, right, and this gets your benzene ring. This adduct undergoes exhaustive hydrolysis. So you add water, one molecule of water like this, and one more molecule of water like this. So the products obtained are, you can see very clearly, there is a ketone, there is ammonia and magnesium hydroxyhalide, which is a very common byproduct. Next is you can do ozonolysis. So in case you need a ketone, you have to ensure that suppose I have taken hydrogen here, so I will get an aldehyde, right, irrespective of what I take here. I can take hydrogen alkyl group. Here I just have to take alkyl groups, alkyl or aryl groups. I can take an aryl group as well. So here let me take an aryl group, right. So what I get after ozonolysis, I will get a ketone here because there is no hydrogen, and I get, since there is a hydrogen, so this is going to be an aldehyde irrespective of what alkyl group I take here. So these are method of preparation of ketones.